This is section 4.5 pre-calculus homework. These are complex numbers in the A plus BI format, and they're asking you to solve for X and Y. So if this is your A value and this is your BI, this is your A and this is your BI, you're gonna set the A values equal to each other. So 3X is equal to 6, then X would be 2. And then negative 4I equals 2YI. The i's cancel, and then divide by 2, so y is negative 2. For 56, you're going to set these two equal to each other, so 8 is equal to 4x. That means x is 2. And then negative 2yi equals 12i. The i's cancel, divide by negative 2, y is negative 6. 57, set the a values equal to each other, so 3 equals 2y. So y is equal to 3 halves. And 4xi is equal to negative 3i. The i's cancel, divide by 4, x is negative 3/4. And the last one, 58, set a 8 equal to 1/2 y, multiply by 2, y is 16. And then negative xi equals 2i. The i's cancel, divide by negative 1, x is negative 2. Next. These next ones, you are going to add, subtract, or multiply. So this first one is asking you to add 2 plus 3i plus 6 minus I. Here are your a values. 6 and 2 is 8. And then 3i minus 1i is 2i. And the answer needs to be in standard form. Number 3, you have to distribute the negative. So 2 minus 8i minus 4 minus 2i. Here are your a values. 2 minus 4 is negative 2. And these two add up to be negative 10i. Next one. You are doing 5/4 minus 7/4 minus 2i. Well, 5/4 minus 7/4 is negative 3/4. Negative 2/4, sorry. Negative 2/4 minus 2i, and negative 2/4 is negative 1/2. This one you're going to subtract, so root 2 over 2 plus I minus root 3 over 2 plus I. These two, since they have a common, these are your a values, since they have a common denominator, you're just going to combine the numerators. So it's root 2 minus root 3 over 2, and then I plus I is 2i. Number 9, you are foiling. 2 times 3 is 6. 2 times 5i is 10i. Plus 3i plus 5i squared. Well, 10 and 3 is 13, so 13i. And this is equal to negative 5. 6 minus 5 is 1. Number 11. Again, you're foiling. Negative 3 times 4 is negative 12. Negative 3 times negative I is positive 3i. 2i times 4 is 8i. And then minus 2i squared. These two add up to be 11i. This is plus 2. Combining it with that, negative 10. Number 13 is asking you to take 2 minus 5i and multiply it by 2 minus 5i. 2 times 2 is 4, so it's negative 10i plus negative 10i is negative 20i. And then this is plus 25i squared, which equals negative, this is equal to negative 25, because I squared is negative 1. Combine your like terms, so you have negative 21 minus 20i. And the last one in this set, root 3 times root 3 is root 9, or just plain old 3. Root 3 times negative I is negative root 3i. And then you have plus root 3i, and this is the difference of two perfect squares. Then minus I squared, which these will cancel. This turns into plus 1. 3 and 1 is 4. Okay, the large exponents of I, what you are going to do is remember that I squared is equal to negative 1. So you're going to take this as I to the 15th power. How many times does 2 go into 15? 7, that's 14 with 1 left over. So if this power is odd, the answer will be either plus or minus I. Well, now you're going to replace I squared for negative 1. A negative 1 multiplied 7 times is negative 1. So this is negative 1I, or just simply negative I. Now if this power is even, 2 goes into 26 13 times with no left over, so this answer is going to be positive or negative 1. It's a negative 1 because this power is odd. So it's negative 1 multiplied an odd number of times gives you negative 1. This is I to the 33 power, so it's an odd exponent, so it's going to be either plus I or minus I. So 2 goes into 33 16 times, it's 32 with 1 left over. Now because this is an even power, this is going to turn into a positive 1. Because negative 1 multiplied 16 times, that's even, is positive I. Okay, this next one. This power, it's hard to read. It says, I think it says 53rd power. So it's negative 1 to the 53rd power and I to the 53rd power. So this is just going to be negative 1. Now this, I squared, 2 goes into 53 26 times. That's 52 with 1 left over. So this is going to be a negative 1 multiplied an even number of times as a positive 1. So you have negative 1 times positive 1 times I, which is just negative I. Same thing. You've got a negative 1 multiplied 107 times. So that's going to be a negative 1. And then you have I multiplied 107 times. So 2 goes into 107 53 times with 1 left over. So this is going to be negative 1. Negative 1, an odd number of times is negative 1. These two negatives cancel, so your answer is just plain old I. And the last one, negative 1 multiplied 213 times, and I to the 213. So this is negative 1. So 2 goes into 213, that would be 106 times, right? With 1 left over. So that's going to be a positive 1. This is going to go to positive 1. With an I here is a positive I, multiplied by negative 1 is negative I. Next. These ones require you to get rid of the radical in the denominator. So you're gonna multiply by the conjugate. The conjugate would be 5 plus 2i. So you're going to multiply 1 times 5, 1 times 2i is 5 plus 2i on top. And on the bottom, you have 5 times 5 is 25. You don't need to do the next two because they will cancel out. And this is going to be minus 4i squared, which is really, this is plus 4. So you have 5 plus 2i over 25 plus 4. So it's 5 plus 2i over 29. And in standard form, it looks like this, 5/29 plus 2 over 29i. 2 over 29i. That is in standard form. 25. To get rid of this radical in the denominator, you're going to multiply both the top and the bottom by 3i. Technically, you could just do I. You could do I over I for this one. 1 times 3 is 3i, and then this is 9i squared. It'll reduce anyway. This is going to be a negative 9. And then this reduces to 1/3. So your answer is negative 1/3 I. So you don't need that I there, or the 3. You could have just done I over I. But either way, if you use 3i, you can just cancel it. Next one, the conjugate for 4 plus 5i is 4 minus 5i. Three times 4 is 12. 3 times negative 5i is negative 15i. All over. 4 times 4 is 16. The next two cancel out. And then 5i times negative 5i is negative 25i squared, which this is really plus 25. And 25 and 16 is 41. So you're going to break this up in standard form. This looks like 12 over 41 minus 15 over 41i. over 41 minus 15 over 41i. Next one. This is asking you what, if you were to distribute this I, you have 1 over 4i plus 5i squared. Well, 5i squared is negative 5. So really you have 1 over negative 5 plus 4i. Minus 5. Okay, so now what is your conjugate? Your conjugate, and I'm going to use a separate sheet of paper because I'm running out of room. So your conjugate would be negative 5 minus 4i. Now you could swing these two around. It doesn't have to be in standard form when you're doing this. But we're going to keep it in the same format. 1 times negative 5 is negative 5. 1 times 4 minus 4i. All over negative 5 times negative 5 is positive 25. Negative times a negative is a positive. Now, the next two will cancel out. This is going to give you a positive 20 and then a negative 20i. And then 4i times negative 4i is negative 16i squared. This is really 16. 16 and 25 is 41. And again, you can break your answer up into negative 5 over 41 minus 4i, or 4 over 41i. Number 31. This denominator has to be rewritten as 4i, and then I times I is I squared, which is minus 1. So if you want to leave this one like that, your conjugate would be 4i plus 1. Now we can FOIL this. 2 times 4i is 8i. 2 times 1 is 2. Plus 12i squared plus 3i. All over 4i times 4i is 16i squared. The next two will cancel out. You have negative 1 times 1 is negative 1. So if we clean this mess up here, we have, this is really negative 12. Negative 12 plus 2 is negative 10. Plus 11i. All over 16i squared is negative 16 minus 1 is negative 17. Now if you break this up into negative 10 over negative 17 and then minus 11 over 17i, these cancel out, so you have 10 over 17 minus 11 17ths i. So those two can cancel out. For 33, you have to get a common denominator. And your common denominator here is going to be 1 minus I, and then times 1 plus 2i. Okay, so what you need to do is multiply this by 1 plus 2i. So this has to be multiplied by 1 plus 2i. So 2 plus I times 1 plus 2i. And then this one is missing the 1 minus I. So 1 times 1 is 1 minus I. So what you're going to do is FOIL this out. 2 times 1 is 2 plus 4i plus I. And then this is plus 2i squared or minus 2. And then we'll just do plus 1 minus I. That's your whole numerator. All of this is that. Now what we can do is FOIL this, because these are both the same. 1 times 1 is 1. And you have plus 2i minus I, and then minus 2i squared. So let's clean this up. We have these i's cancel, and the 2's cancel. So you have 1 plus 4i on top. All over, we have 2i minus I is I. This is really 2 plus 2. 2 and 1 is 3. Now what's wrong with this problem? This is the simplified, this is adding up those two fractions, but now you have to multiply by the conjugate. Oops, 3 minus I. So, because you can't have a radical denominator. So 1 times 3 is 3. You have minus I plus 12i minus 4i squared. All over 3 times 3 is 9. The next two cancel out, minus I squared. This goes to 10. You're going to simplify, this goes to 4. So 4 and 3 is 7 plus 11i all over 10. And you can break that up into 7/10 plus 11/10 I. Moving along, number 37. How do you rewrite these without the negative radical using the I? Well, the square root of negative 36 is 6i. This, you just take out a negative 1, so it's root 14i. This piece is 4i, so it's negative 4i. This one is written as 4i plus 7i, which is 11i. 45, we have root 15i minus, this you can take out a 3. So this is 3 root 2i. And there's really nothing you can do there. You could factor out an I. You might see this answer written as root 15 minus 3 root 2 in parentheses I. (47). This numerator is 4i. The bottom is 6i. The i's cancel, and 4 over 6 is really 2/3. 49, this is 5i plus 2 times 7i, root 49 is 7i minus 3. Now you're going to FOIL. 5i times 7i is 35i squared minus 15i plus 14i minus 6. This is really negative 35. And negative 35 minus 6 is negative 41, and this is negative I. 51, you're going to rewrite these two. This is 2 plus root 5i times 1 minus root 10i. 2 times 1 is 2. 2 times negative root 10i is negative 2 root 10i plus root 5i, and then this is going to be negative root 50i squared. So this you can take out a 5, and you can make that a positive. This is going to be a positive 1. So this is 5 root 2, and it's a positive now. And these two can go together, but it's hard to add those two coefficients, but you can factor out a 2. So this answer, I would just leave it as this. Now this turned into 5 root 2 because this is negative 1. Negative 1 times negative 1 is positive, so this is 5 root 2. And this last one, you are going to have to multiply by the conjugate. I would write this as root 2i. You're going to multiply this top and this bottom by 1 minus root 2i. Stop it and I'll finish it.